Okay, Utkarsh. So what you're saying is that there are vectors of weights which are the points that are to be clustered. So where do these weights come from, and where do these vectors of weights come from? Because all we have is those PDF documents or maybe the text.
So Rohit, for one word we can train the embedding, and it would give us a vector for a particular word. But for a
Then
sentence, I
once again, when we are coming to embeddings and other things,
right.
all that needs to be done before we go to the KNN, or we are talking about something separate than KNN.
So this is something separate than KNN. So what happens is that so to calculate a
Well,
similarity between two,
Deepak, 1 second. See, the TF-IDF approach is one thing. That is what is
right,
happening. GenSim and other things are one thing.
right,
But I have shared a lot of content with everybody in which people are doing text similarity and this thing using pure KNN and nothing else. Right? So
okay,
Utkarsh has
so
also shared one document. I'll share those documents with you also. So what we are
sure,
trying to see, my approach is very, very simple.
sure.
If we achieve results with KNN, why should we go to something like GenSim, or why should we even go to NLTK? Or if
Yeah,
we go
yeah,
to NLTK, then we should understand why we are doing something, and everybody in the group should be able to understand that very, very clearly. Now, if I
yes.
ask Piyush, can you explain what is the discussion we are doing? And or if I ask Tapendra, so or Rohan, all three of them should be able to tell me ki yaar Rohit, this is what it is and this is how it is to be done. And I have understood either from Deepak or from Akshat or from Utkarsh or from Abhishek. So the people who are aware, let's first chalk down. I don't mind even if you just write on a very simple page of uh, Piyush, what are you saying? Yes, Piyush, are you aware? What about
Yes,
NLTK?
you are saying about NLTK discussion,
बताओ,
what we have done.
tell me about NLTK.
What we have done that oh, for PDF, we are chopping the PDF into two part and extract the data.
Then where does the NLTK come in that? What is happening with the NLTK?
I don't know the discussion we held in
That's
which
what I'm
we have
saying.
discussed.
So
Hmm.
wait, don't worry. You don't have to worry. When I'm asking you something, I know that you are not aware, and that's the reason I'm saying you don't have to worry about it. It's not as if I've questioned you. You have to give me an answer. It is not that. What I'm trying to say is that whenever we are doing any of these things, it should be made so simple that anybody in the team who has not done these things till now should be able to understand. So let's say that we have understood that okay, with the PDF files, we will go to some this thing, we will break them down into paragraphs. So we've already done that. So from PDF, whether we use imaging and then we use, get it into text, or directly we are going to that, what Shubham has done through the link by web scraping, we are directly getting to text. And Shubham did a wonderful job on that. He web scraped also within the same script, and he's also given us he's gone till the TF-IDF. Fine. Now, what I'm trying to understand is for doing something like KNN, let's keep TF-IDF as an approach separately. Let's keep NLTK and other things separately. The PDF documents that I shared with all of you, which were focused on KNN, I don't think so. Those documents are using NLTK or GenSim or any of these things. Maybe they are using TF-IDF because I read somewhere in one of those documents TF-IDF is mentioned. So they are creating those vectors. They are doing all of that, term frequency and all that. They are calculating, which is okay. Next step, how are they getting into KNN? So that is what we need to do. So that should be one approach. Once we are done with that approach, then we try maybe multiple different scripts for that, and then we say okay, maybe KNN is not the best choice. So we don't know why so many people have published so many research papers and things like that. Maybe what they did we could not achieve, so forget it. So then we will drop it. Then we will look at TF-IDF and further whatever we can do with that, right? Then maybe some cosine similarity, other distances and all that stuff is what we are looking at. Then we might want to go to say something like NLTK. Then we might want to go to Jensen. We'll have to explore all of these approaches, because I'll tell you the reason. This NLP task of yours from learning perspective is not only restricted to patent spike. So it is not only in patent spike that you will end up doing NLP. NLP you will do in 1,000 more things within these projects. Okay. So firstly, you have to become experts in NLP, in generic NLP. Now what is happening is most people in most organizations, what they are doing is they are picking up one particular very, very specific task and they are solving for it. But we cannot be doing that, because why? We are going to the market with a product. We are going with a generic product. So at least 4 to 5 different NLP tasks, 4 to 5 different NLP pipelines should be able to solve and implement. Then it is, we can say that yes, this is a product which is focused on text processing or natural language processing. Deepak, have you understood what is the plan? If you can just tell me quickly what you have understood, so that I can
Yeah, sure. So basically, we have these patterns. We chop them into two parts. Then we extract the text, and now we are trying to uh, correlate between two abstracts or two sentences, whether they are similar or not. Now there are multiple approaches. The first one that we can go forward with is KNN, which is basically you. So I'll not go into detail. So one is KNN. So first we will try KNN, then we'll explore other approaches, and finally we'll basically compare which one gives the best output.
right. Yeah, great. So if everybody is okay with this, then as a next step, we should start looking at, see, we already got that scraping script from Shubham. That script all of us have. If somebody doesn't have, you let me know. I'll again share that with you. Okay. So with that scraping script, we'll get the text of the this thing, the patent document. Now let's take that patent document and let's start working on the KNN, pure KNN approach. When I say pure KNN approach, if there is something that we have not understood, then let's discuss it. So few things I want to share with you, and this I've taken from scikit-learn. So while Utkarsh is saying, Rohit, why should we go to library? That's okay, but scikit-learn is one of the popular ones. So whatever implementation they have done, I believe that they must be doing something great. I have not on that our this thing task. I have not used it, so I really can't say. But here are a few things which I have noted down, and I'll just try and understand. For estimated to be effective distances between neighbors should be less than some distance d. So what exactly is our neighbor? That first thing we need to understand. So now Akshat has given some answer that Rohit, this is Utkarsh has given an answer saying that this is what our neighbor will be, and Akshat is also aware of this. Okay. So at least two of you can, probably post this in Slack also. What I'll do is I'll just take a screenshot of this right now, and I'll post it in Slack saying that both of you have mentioned this, and then you guys can further, just top it off with some details saying that this is what it is and this is what we meant on the call. So that's okay, and the call recording also I'll share. That's it. The next thing is, in one dimension, this requires an average of something points. So what it is talking about is one-dimensional this thing. So is our problem a one-dimensional problem for KNN, or is our no Utkarsh, we will not go to TensorFlow and other things right now. See, TensorFlow and everything, if I ask you, so you will say yes Rohit, I know TensorFlow. Maybe Akshat knows TensorFlow. Okay, maybe Deepak knows TensorFlow. But there are other 40 guys in the team who will not understand TensorFlow, and going right now to TensorFlow is not okay. So that is not what I want to do. Whether it is TensorFlow, PyTorch, Keras, all of these things, earlier also, I don't know if you guys, yes, of course, you were there on that imaging call initially with Varun Singhal and Manish Kumar and everyone. So there also I refused. We will not use deep learning straight away. First we'll use something which is statistics based, then we will go to machine learning, then we'll go to deep learning. Deep learning I don't understand. I don't know if you understand. You'll give me a solution, I'll try and plug it into the system. Tomorrow it doesn't work. I really don't know. I'm not confident on that myself, right? So that's what it is. So I just don't want to use something which is a black box. If you take responsibility, let's say Utkarsh and Akshat and say Deepak take responsibility, saying that yes, let us solve it with TensorFlow and let's explain TensorFlow to everyone. So me, Rohan, Tapendra, Tejas, and Abhishek, we say yeah, wonderful, we've understood TensorFlow. Then I'm okay with that. But I don't think it is practically possible right now. Right? Utkarsh, you agree with me? I don't want to force you. If you say, nahi, Rohit, we can do that, then I'm okay. But I don't think so it will happen. TF is not something which is, which will give... yeah, so let's try and continue with sklearn. The code which we will end up coding will be easy for all of us to understand. We don't reach the results, let's then again move to TensorFlow. I'm not forcing anybody. There is no this thing to hurry up into these things. Okay, then so we're talking about they talk about one dimension. This requires an average of some something points they've given over there. So is our problem in one dimension or is it in more than one dimension? How will we understand that? That is the next thing that needs to be understood. Okay, then they talk about one feature. They say if we take up one feature, which they have given example of the iris data set, so which is very simple. So they just take maybe petal length, petal width, or whatever is there. So they say, okay, this is what we've taken. And then they are saying so many observations for one feature will be in the training set. Okay. Then they said new data will not be further away than 1 by n. Therefore, NN decision rule will be efficient as soon as 1 by n is small compared to scale of between class feature variation. So I've written this down. I didn't understand this. What is it that they're trying to convey? Their code is not related to this. I tried to Google a lot of code. So scikit-learn approach itself of KNN seems to be a little weird. I don't know what it is. Right. So these things we need to understand. And the link I'm talking about, let me see if I still have that open. Is this one. I shared that with all of you earlier also. I'll just put it here in the chat. So these things we need to understand. If we don't understand these things, we can't really, go into production with this thing. Yeah, so then he starts they start talking about the count of features is p, then this much points. If 10 points in one dimension, then 10 by p points required in p dimension. And then they talk about the curse of dimensionality. And this is the moment the number of dimensions increase, then the space increases, and because the space increases, our data sets become sparse. So I understand sparse metrics and all that, but I don't understand what are they talking about. Why are they talking about space increases and all of this stuff? So I'm not very clear. So they say dimension increases, volume of space increases, data becomes sparse, sparsity of data is not good. Yeah.
Rohit, are you not sure about the dimension, this particular concept, or what? Curse of dimensionality or what?
No, what I'm saying is that the curse of dimensionality, okay, generic concept, I understand what they're talking about. But what I'm trying to say is, how will we understand in how many dimensions is our data? This problem that we are doing with patents, how many dimensions is it? Is it a 2-dimensional problem? Is it a 3-dimensional, 4-dimensional, or n-dimensional? If it is n-dimensional, how do we define that?
So it will depend on, so these are basically features. Number of dimensions equal to number of features are there for one particular example. if you think of a tabular formatted data for machine learning, then so if we are going sentence by sentence, then there will be multiple features for a sentence.
So
Whether
what
how many
so
so
what you're
so let's
basically
say
saying is,
so let's say we have a sentence and one feature can be how many words it has. So this is one dimension. And then you can have other features which could talk about other things of that particular sentence. So yeah,
right. So okay. So what you're basically saying is, if I look from a very basic understanding, then
yeah,
the dimensions over here are
yeah,
basically my independent variables, right?
yeah,
What we usually call independent variables.
yes, yes,
Okay. So which
yeah,
which also then further means that we will have to go ahead and do some feature engineering. So we just
yes,
can't throw text at the problem and expect some results. We will have to do
yeah,
feature engineering, right?
yeah, exactly.
Abhishek, you want to say something?
Yeah, yeah. Actually, the papers that you provided, I went through them. So I just got a finding that I like to share that is relevant to this topic. So there is a paper which says that you have to select the number of dimensions for your this process. And the problem is that the more you dimensions have, there will be more noise. As you said, the curse of dimensionality. That's the word that they mentioned. And in order to solve it, they gave a formula depends on the number of classes, and classes are the number of categories, basically the different categories of text that you have. So it depends on the number of classes. They uses some logarithmic functions and floors and seals, and then they finally arrive on the number of dimensions, and typically they cap it to around 1000. And then depending on that, they use feature selection, and there are various methods of feature selection to reduce the existing dimensions to the required number of dimensions.
Excellent, wonderful, Abhishek. Now, see, now here comes another challenge. We don't know how many classes they are. When we are trying to classify the patents, we don't know
Yeah.
how many different classes of patents they are. So that
Okay.
brings us to our initial problem. Our initial problem was this only,
Okay.
which Rohan and Akshat and everybody we were struggling with.
Yeah.
We were not aware on the how many different types of patent documents are there. So how will we get to the this thing of similarity?
Okay, I got your point. So basically, in our use case, we cannot use that formula that is rendered useless for us.
No, I'm not saying it's rendered useless.
Bec-
The point
no,
is that we will have to understand how many classes are there, or we will we will say that in the real world, in our population, so to say, we don't know how many classes are there, but we picked up a sample. Maybe we picked up a sample of 10 patent documents,
okay,
and using that sample of 10 patent documents, we'll say there are 3 classes in this. So we are trying to predict whether it is class A, class B, class C.
okay,
Okay. And as
yeah,
an example of, say, class A, class B, class C, at a very basic level, class A will have assignee, and there'll be multiple guys who are the patent this thing creators or something, and
yeah,
the class B will not have a assignee, and there'll be a single guy who's the patent creator, and third class will again be something like that.
okay.
Rohan, you remember what we were initially doing, what we were trying to do initially. So does this make some sense?
Yeah, so basically we have to just understand how many classes there are. That's one thing we have to find out.
Yeah. So all of these approaches, the baseline approach is that what we guys understood. So that all of us will understand the baseline approach is that we need to understand how many different buckets are there, and whenever I pick up a patent, in which bucket should I put it, and when within those buckets there are patents, then further similarity will be there. So maybe those buckets become smaller, and the number of buckets increases over a period of time, and that is what the k nearest neighbor in a very generic way does. So taking whatever features, like Deepak said, we will have to do feature engineering. After doing that feature engineering, picking up those features, we will ultimately have to bucketize these text documents into different buckets. So yeah, that is the task. So we have more clarity on the task also.
Uh,
uh,
One more thing I wanted to, like, I had a doubt that there was this. You had just mentioned that the buckets will be, will move ahead. Uh, Basically, you meant that there will be buckets that will be like it won't be stationary. Like when we are defining these buckets, they have to be like classified into only some, right? You can't increase them again and again, because when you're classifying, it has to be only a few of them.
See, the point is like this. Let me give you an example. Okay. Uh, Rohan, I'll give you an example. You please, see, let's say I say within this group, okay, within this group, we are looking at three, this thing. One is height of the person. Second is with what alphabet your first name starts. Second is, third thing is with what alphabet your second name starts. Okay. So first thing is height is simple. So we'll all just stand together and we'll say, okay, fine, these are this thing. And I want to create three different buckets of heights. What I will say is initially the tallest guys, the guys in the middle, and the short guys. Okay. So all of us will come into that three different buckets. Then within those buckets, I want to further bucketize, saying that everybody whose first name starts with A, or everybody whose last name starts with K, right? So that will be the second category. So that is where, and let me give you an example. Let's say there is a patent that talks about software which is created, say, using Python and JavaScript. So that is the first category. So let's say we pick up 10 documents like that. Next comes that software which is made using Python and JavaScript. What does that software do? Is it network security? Is it a desktop software? Is it a web app? Is it this? Is it that? Right? Then comes the third category. Does this patent belong to an individual person, or to maybe 10 to 12 guys who have patented it? Then comes the next category. Will this patent have an assignee, or will this patent not have an assignee, and things like that, right? So if you look at USPTO, or if you look at Google patents, those guys also give an advanced search option wherein they are giving all of these categories, right? If you look at the URL that I've sent to all of you for that web scraping one, if you break down that URL itself can be broken down into some kind of categories, right? I think I remember I shared two with Python and something else with all of you, on which one of those Shubham has worked on that to get the text down, right? So all of these things we will have to consider. And so that's what I'm saying. So it is not such a simple task that we'll end up classifying into, say, 4 buckets only, and we'll say, okay, we will stick to 4 buckets. We cannot do that. Initially, we may be sticking to 4 buckets. Then we might have more than that. Then within that also, we will have to break down. Yeah, Deepak.
Rohit, if I can add to what you're saying, I think if we break down our task in 2 steps, the first step is that we do unsupervised clustering of the patents, and we then we analyze all the classes that all the clusters that we are getting. We try to see what kind of documents are coming in a particular cluster, and that's how we come up with the what kind of classes we can have. So we take like n number of random patent documents, randomized documents, and then we come up with the number of clusters, and then we analyze the clusters, what kind of documents are coming there, and that's how we come up with the classes, I guess. And then we further develop a model for those particular classes.
That's great, Deepak. That's an excellent suggestion. But again, Rohan's question comes from that doubt that, Rohit, how many this thing will we ultimately have? Rohan, I don't know. To tell you frankly, even if we take Deepak's approach, which is the correct approach, then also we will not know that ultimately when an unseen patent will come to us, whether it will fall into the clusters. Let's say we, in today's date, we pick up 100 patents also. Let's not go beyond 100. Let's pick up 100. Out of 100, we will say, in an unsupervised manner, we will get, say, 11 clusters, just as a number. Okay. Then again, whenever an unseen document will come to us that we have not seen, we really can't say whether it will fall into these 11 clusters or it will so to say it will be an outlier. So if it is an outlier, then we again have to understand that is that the only unique document of that kind. So we can say, okay, fine, this is the 12th cluster. And then maybe over a period of time, when we start doing this, then other documents will come in and they will fall into that one of those 12 clusters. So it's a dynamic problem. That's the reason somebody was asking me yesterday that this kind of project, what is the timeline you have and all that stuff. I said, how can I give a timeline for such a thing? We cannot, because we want to put this into production. If we put it into production, what will come through to us, we really can't predict. And then again, we will have to somehow change things. So that is how it works. So when you look at any of these, when you and let me be very clear. If you guys don't understand what I'm saying right now, you please ask me again, because this is a very, very, very critical point for us. When you look at any of the hackathons, when you look at any competition on Kaggle, when you look at any of these things, those are static data sets. Those are static data sets of some problem that an organization is dealing with. So it's a snapshot in time. Whether it is data for 6 months, whether it is data for 1 year, 20 years, or whatever, it is a snapshot in time. So while the competition is going on, unseen data is not coming through to you. It's not as if it's a ongoing this thing. But in our case, we might have to end up doing something very basic. But when you put it into production, ultimately, then unseen data will come, and we really can't say. So the system has to be such, like Deepak has suggested, system has to be such that whenever unseen data comes, if creation of another cluster is required in an unsupervised manner, let that another cluster get created. You get, does everybody understand what I've just said? So this is very, very important for us to understand from a conceptual point of view. How we will solve for it, we will see. That we have to see. Deepak?
Yeah, I totally agree with you.
Yeah, so in production, you can't go with the mindset of having a static this thing. So that's the reason. Other day I shared a lot of things with Akshat also. That's the reason when Akshat said that Rohit, churn is my next target, I've shared so many different kind of approaches and things with him, that if you put something of that sort in production, it should at least be able to tackle 4 to 5 slightly different use cases. Then it is okay. Then you can say, yes, I am offering this as a production software to people to use. Otherwise, if it solves only one particular data kind of problem, then max to max you will get 2-3 clients. That also you will have to hunt for them to get them and get them onboarded onto your system. But then that is not something which will work out very well for us. So we will struggle a lot. But max to max, what we will be able to do is that in 1 or 2 companies, there'll be 2-3 data analysts who are sitting, whose job we can make easy. Besides that, we will not achieve much.
So, Rohit, I understand that this problem is dynamic, and even if we finalize some number of let's say classes, we might see some new classes on the unseen data. But still, whatever data we have, let's say we have let's say 1 crore patents all across the world. If we do some kind of clustering, if we have some kind of infrastructure, we can come up with a particular number of classes. And if we see any new kind of document in the future, then we might think about that, because we would have to finalize the number of classes.
No, I agree. See, Deepak, I'm agreeing. I'm not saying कि we will not do that. Okay.
Yeah.
मैं कह रहा हूँ हम वो करेंगे. I'm in total agreement with you. So fine. So now I think we have 2-3 different tasks which we are already kind of okay with. So there's another call which is there now. I think all of you are supposed to be part of it. So if you're okay, we'll disconnect this call and we'll join that one. Okay. I'm requesting all of you to be on that call also.
Sure.
Perfect. Thank you so much. Thanks.
Yes.
I'll share this video with everybody right now.